Chapter 2, Review of Probability. This chapter reviews the core ideas of the theory of probability that are needed to understand regression analysis and econometrics. We assume that you have taken an introductory course in probability and statistics. If your knowledge of probability is stale, you should refresh it by reading this chapter. If you feel confident with the material, you should skim the chapter and the terms and concepts at the end to make sure you are familiar with the ideas and narration. Most aspects of the world around us have an element of randomness. The theory of probability provides mathematical tools for quantifying and describing this randomness. Section 2.1 reviews probability distributions for a single random variable, and Section 2.2 covers the mathematical expectation, mean, and variance of a single random variable. Most of the interesting problems in economics involve more than one variable, and Section 2.3 introduces the basic elements of probability theory for two random variables. Section 2.4 discusses three special probability distributions that play a central role in statistics and econometrics: the normal, chi-squared, chi-squared, and F distributions. The final two sections of this chapter focus on a specific source of randomness of central importance in econometrics: the randomness that arises by randomly drawing a sample of data from a larger population. For example, suppose you survey 10 recent college graduates selected at random, record or observe their earnings, and compute the average earnings using these 10 data points or observations. Because you chose the sample at random, you could have chosen 10 different graduates by pure random chance. Had you done so, you would have observed 10 different earnings, and you would have computed a different sample average. Because the average earnings vary from one randomly chosen sample to the next, the sample average itself a random variable. Therefore, the sample average has a probability distribution, which is referred to as its sampling distribution because this distribution describes the different possible values of the sample average that would have occurred had a different sample been drawn. Section 2.5 discusses random sampling and the sampling distribution of the sample average. This sampling distribution is in general complicated when the sample size is sufficiently large. However, the sampling distribution of the sample average is approximately normal, a result known as the central limit theorem, which is discussed in section 2.6.